we will present with Julien some projects that we are working on now in Switzerland. The first project, it's an office building in Lausanne. In the main city, it's the building that you see behind this picture. Need to comply with fire standards, 60-minute fire resistance. It's a building made of steel and concrete, has been built in the 70s, I think. And it's one of our main clients in Lausanne. This office copes with all the buildings of the Canton Vaud, so they're working with around 1,000 buildings in our region. It's one of big clients. So this example is very good to show because it's a very simple one, but we will see that the expectations were very high and the savings at the end are very high too. So we did analyze this building with advanced method because we will see that the ISO approach is not good for this case. So we did, as we always do, ISO fire calculation, natural fire analysis with zone model. Then we did some natural fire with FM coupling with SAFIR. This is the structure. This is quite simple composite floor with beams and deck and slab. That's the main zone is 800 square meter. So we did the analysis quite a simple one. So we used to do this with beams and shells. I will not explain as we are all experts. The first step is to always do the ISO fire calculation. So we have a reference time for the resistance. You see that with ISO fire we have only 26 minutes resistance, as we always use the criteria on this the 1/3 out of the dimension, and we consider that there is no way back for the structures. Then we use a natural fire analysis with the zone model. We did with ozone. You can see the left side, the scenario, we can reach a quite higher temperature with this model. We did 3 scenarios, one with 800 square meter and the other one with the half of the surface, but you see that we all are in a bad situation even with zone model. So we go further and we switch to CFD model. So we done FTS model with two strategy. One, the simple one to start with, one or two compartment, which we model all the condition, and especially the ventilation condition in this building are very good. So we thought that will be a good point to get lower temperature in this compartment. As we see, the behavior is quite good and the temperature will not rise too high. And the second model, we did more complex FTS analysis. We put some wood blocks and ribs all the compartment, and we have something that it looks like a traveling fire. And at the end, at 30 minutes, we have a full engulfed fire. So we have the highest temperature. So you can see here, the two models are quite similar, but the fire development is not the same. And then we checked the deformation of the slab with SAFIR. So we did couple FTS and SAFIR for this simple model. And you see at the end that we only have permanent deformation about 6 or 7 centimeters. So we can consider that the structure stays safe quite forever after the fire. The result of this simple, quite simple project is the dimension is quite small, but you can see that the savings are quite huge. the costs if we had to protect the structure for 60 minutes were 100,000 francs or euro. That's quite a lot. And this building has 5 floors, so we saved for our clients 500,000 Swiss francs. With 2 weeks of work, so yeah, I think it was worth the investment for the client. I let Julien continue for the second presentation, then we can have the question together.
Second case study we wanted to share with you is a risk analysis focused on electric vehicles in existing parkings. So we got this mission in a project of the city of Lancy near Geneva in Switzerland, consisting in adapting existing car parks to electric mobility. So our goal for this project was to develop a fire safety concept in order to manage the risk linked to electric vehicles. So the first step consists in the literature review on the measures recommended in the different legislation in European countries. As in Switzerland, there is no specific recommendations to manage the risk linked to electric vehicles. So there is no main difference in terms of design between car park with electric vehicles and car park with standard vehicles. And the second step consists in developing the fire safety concept based on the NFPA 550. So the goal of this concept was to identify key elements in order to achieve the safety objectives. So for this project, of course, the safety objective is to ensure the safety of people and firefighters. So with specific propositions, specific safety measures based on performance-based design. So here is the parking we are studying. The study is still in progress. So this is a residential and office building with a covered car park with concrete structures, concrete slab, and concrete columns. So we developed our safety concept based on the NFPA 550. So we have here an example. So this is a fire safety tree. How it works, so we have the safety objectives on the top, and then you can achieve these objectives with two manners, two possibilities. The first one is to prevent the fire ignition or to manage the fire impact. So for this project, we were focused on three main safety keys. So the first one is not a main key, but an important one, consists in prevent fire ignition. So of course, the lithium batteries are a bit complex, so it's difficult to manage the behavior of batteries. So difficult to have very efficient measures on that point. So we propose to implement infrastructures adapted for that specific risk based on legislation. So, for example, with specific chargers, with a good safety barriers. For example, like battery management system that we can find in batteries. We have basically the same for the chargers, which offers good safety level. So this is an important point, but our concept will focus on the second branch of the tree. So here, in order to manage fire impact. So we have two possibilities to do that. Either you manage the fire or you manage exposed. So the first key that we studied, that we assess with performance-based design is controlling the fire by construction. So for example, implementing walls split the parking spaces in order to limit the fire spread. It can be also a sprinkler installation in order to contain the fire. So these two measures seems to be quite interesting, but we have to assess the efficiency for the specific parking. And the second part, so manage explodes. So of course we have to ensure the resistance of the structures in fire situations in order to ensure evacuation of people and the integration of firefighters in good conditions. So in order to choose good solutions, good safety measures, we use performance-based design with CFD model coupling with FEM calculation. So here are our three main scenarios we studied. So the first one in the left is the existing situation with no specific measure for that car park. The second one is the existing situation, but improved with walls every 2 or 3 parking spaces in order to contain the fire, to limit the fire spread, and also the heat release rate. And the last scenario is the same as before, as the second one, but with a sprinkler installation with the N2 class. In Switzerland, this is the sprinkler installation that we recommend for standard car park. So the scenario, the fire scenario is the same for the 3 cases. We have an initial ignition of one car on the left in red, and then we imposed the fire spread to the 2 other vehicles after 2 minutes on the basis of literature. And after the fire spread is function of the temperatures received by the vehicles. We used an ignition temperature condition of 300 degrees in order to take into account the ignition of the wheels of the vehicles. On the right, we have the fire design curve, which is quite new in Switzerland. This curve is based on very recent experimental test, and this curve is recognized by the Swiss authorities to be adapted for electric vehicles because the plateau at 8 megawatt consider the thermal runaway of the battery. Here is the one of the first output that we studied, quite interesting. This is a screenshot after 60 minutes of fire. So on the left, without any measures, we can see the fire spread. Also with just war, but later than the existing situation, and with the sprinkler, the fire spread occurs, but later. So on the right, we have the 3 heat release rate curves in function of time. So we see the difference between the 3 scenarios. So of course, in the existing situation, without any measure, there is nothing to limit the fire spread. So we get a high heat release rate around 90 megawatt after only 40 minutes. Whereas at the same time, we have just around 30 megawatts with the wall contained fire, and around 15 megawatts with the sprinkler. What is interesting is to see that with sprinkler, we have a limitation of the heat release rate, and then there is the cooling phase here, but after 60 minutes, we can have the fire spread, even if the sprinkler installation is here. Here are the results in terms of thermal stresses and adiabatic surface temperature. One other interesting output with the existing situation is that the AST curves fit quite well with the ISO fire curve, so which is quite consistent with the standard fire scenario if we have no specific measure. And then with the wall containing the fire, of course, we have locally high temperatures due to the initial fire. And then the fire spread and we get a high temperature, but later after 60 minutes. And with the sprinkler scenario, it's quite the same, but after around 70, 80 minutes. So of course, we used the CFD results in order to couple with SAFIR to get the mechanical response of the slab, of the concrete slab. So on the top, we have the situation after 30 minutes, and on the bottom, situation after 60 minutes. So in terms of displacement, we can see the difference in terms of behavior because without any measure after 60 minutes, we have very high displacement around 60 centimeters, which is not acceptable. With the wall, the results are quite good, but still high displacement with 40, 60 centimeters. And with sprinkler, we limit considerably the displacement. So this study is still in progress, so we have to study a few more scenarios. So we saw that with the sprinkler, with the N2 class, we get the fire spread after more than 1 hour. So our objective is to study the impact of sprinkler installation, but with N3 class, so with an active area of the sprinkler increased compared to the N2 class in order to check if we can manage the fire and contain the fire better. And that's all. So we are ready for your question. Thank you very much.